Video D1, Production in the Short Run. In this section, we turn to the production process or the supply side. We're interested in representing the inputs that go into production and how those are put together in order to provide an output. Let's start with the idea of a production function. The production function expresses how much can be produced in a particular period of time by a particular firm or perhaps a collection of firms. We sometimes write it as a mathematical function that the quantity that is produced is a function of the material inputs to production, the labor that is used, the capital, or I will call it here just the equipment, the buildings, vehicles, machinery, and so forth that goes into production, the way in which that is all combined, which we call technology, and finally, the existence of the firm itself, we can say is a function of entrepreneurship. The production function then encompasses how all of these different inputs to production are combined in order to produce an output Q. We distinguish between what we call the long run and the short run when we look at a production function. In the long run, we mean a period of time in which all of the inputs can be varied. Contrast that with the short run, a period of time in which at least one input is fixed and cannot be changed. Let's provide an example here. In the short run, let's let quantity equal 3 times the square root of labor, and let's have that represent the number of people per hour that can be served at a convenience store. It's useful to think of this production function, Q equals 30 times the square root of L, in terms of both a table and a graph. Looking at it as a table, we can think about using different amounts of labor as an input, say 0, 1, 2, 3, 4, or 5 units of labor, and that labor in the short run, combined with everything else that is fixed for this period of time, results in a number of customers that can be served. Well, if we have nobody working, the doors are going to be locked and we're not serving anybody. But the very first person working in the convenience store can now serve a number of customers, say 30. And let's say we can serve up to 42 people per hour with 2 people working, 52 with 3, 60, and 67 when we move up to 5 people per hour working in the convenience store. We can move over and think about this in terms of a graph. On the horizontal axis, we'll now have the amount of labor, and on the vertical axis, we'll have the total production. So if we look at 1, 2, 3, 4, and up to 5 units of labor used, we start at 0 production. Let's put in axes going up to, say, 75 for the total amount of production. That lets us put in a 50 and a 25, and we can sketch then at 1 unit of labor, we end up with an output of about 30. At 2 units of labor, an output of about 42. At 3 units, an output of about 52. At 4 units, we have an output of 60. And finally, at 5 units, we have an output of about 67. What we see is that our production function, this is Q, equals 30 times the square root of L. It doesn't show a constant slope, but rather it shows a slope that is constantly getting less and less, or smaller and smaller. We call this diminishing returns, or a decreasing marginal product. Marginal product is the additional output that is produced by one more unit of the input. We can move over back to our table now, and we can also look at what happens to the marginal product. It's always specific to one input, so this will be the marginal product of labor. So translating this into something that we can calculate and put numbers in, we're looking at the additional output, the change in Q, divided by the additional input, the change in the amount of labor. We don't start until we have 1 unit of labor, so that we have a change between 30 minus 0, our initial 30 units of output, divided by 1 unit of labor, which we have added. So that gives us 30 for our marginal product. The marginal product of the second unit of labor would be the additional 12 units of output we get, 42 minus 30, divided by 1 unit of labor. So that will be 12. And we can continue down. You can fill in the calculations that the marginal product between 2 and 3 units of labor is going to be 10, and then next will be 8, and then next will be 7. 30, 12, 10, 8, 7. This is showing our decreasing marginal product. It is this decreasing marginal product that is the reason that supply curves slope upward typically. This is easily explained by thinking about costs. Supply curves are representing costs, and if we're getting less and less output for each unit of labor, for example, we still have to pay each unit of labor the same amount as the previous unit. So each unit of production is getting more and more costly. That is, the marginal cost of production, or the supply curve, is increasing.